for the first part. Wow, just 1 hour. Okay. Any question about the before we go we go to the for the exercises? Alright.
Yes.
Ada masalah ke? So we just got four participants today. Four, eh? Right.
Point.
So Nurul Azmi, okay. So how we want to take a short break or we continue to our exercise? We have gender, age, height, and weight. So this one we will continue our exercise in single linear regression. So okay, let's do together using data analysis tool pack. Okay, first you go to the data. Okay, the objective of this exercise, we want to know the relation between weight and height. So weight as a dependent variable and height as a independent variable. Okay, so weight is y and height is x. So we go to the data analysis and then we go to the regression. Okay, this one you put y, select the weight, all the weight data, and the input x you select the height. Okay, and then don't forget to tick on the labels. So the analysis will exclude the label and then click the label. Okay, this one I want you to click the line fit plot. So okay, and then you just click OK. Yeah. So this one we also get the high line fit plot. Okay, this is the result. Okay. You get the same result?
Tak dapat.
Boleh dapat tak?
Tak dapat.
Or you want me to repeat again?
Yes.
All right. Okay, sorry. Okay, we repeat. Okay. So in the demo MLR, we have several variables, but in this exercise, I just want we to revise about the single linear regression. So we got height here and weight of the several respondents, female and male. So the age you just abaikan. Okay. Okay, height and weight. So weight we put as our dependent variable or y. So height as the x. So the objective here, we want to make a regression weight and height. So we go back to our data analysis tool pack. You go to the data and then the data analysis. Okay, find the regression. Okay, so then you click OK. Okay, in this regression box, so as I mentioned before, input y or dependent variable, we choose weight. So we select from the label until all the data. Okay, then we click here. Okay, you see, we click here. So it's already in our Y box. So for the input X range, we decide to put a high as our X or independent variable. We click here, then we select all the height data. All right. So we already put our independent and our dependent variable. And then don't forget to tick at the labels. So the analysis will exclude the labels. And then we click the confidence level as 95%. And then this one, I want you to click at the line fit plots. All right. So we can see how good the regression is. Okay, so then you click OK. So you can see the output result here, right?
All right.
Okay, good. So we get the R square 0.6 and the adjusted R square 0.59. So we can say this regression is uh, good, not best, but good. We can see here in the high line fit plot, we can see the tabulation of weight, original actual data, and then this one is predicted weight. So it gives uh, uh, the fit plot here. All right. So how can we generate the equation? So like from the slide I mentioned, we see at the coefficient here, intercept and height. Y equals to negative 132.991 plus 3.8181 times the height. Okay, so for the hypothesis testing, we can see F is more than significant F. So we can reject H null and accept the H alternative, which means the regression model is fit. We can use this regression model. So this is the result from the data analysis. How can we compare? Okay, we put it here. So if you get a not confusing or not so not or we forgot how to generate, so I can show you the next way, the next step. Okay, you select height and weight here, and then you go to the insert, and then you go to scatter plot. Okay, this one. So we want to know the relationship, the R value. You go to the plot, and then you right click and you add the trend line. So we have the linear trending linear here, and then you set the R square value. So equation. So the set the intercept. So already generate the wait. Oh, sorry. This one is this one is not the question. R square. Sorry. This is just a weight. Okay. Forget this one. But focus on the the regression result here. Okay. Wait. Okay. Get the trend line. Okay. Oh, yeah. That's one. Yeah. Yeah, this one. 0.6. Okay. So this one. So how can we get our formula? We just click at the blue plot, not the orange plot. Then we right click, add the trend line. Okay, don't forget to display the equation and then display R square. So this is the easiest way you to find your formula and your R square value. Alright? So saya cepat sangat ke ataupun saya nak ulang balik cara saya nak generate?
Ulang balik doktor boleh?
Boleh. Alright. So I will repeat. Okay, how can we get the formula, the regression formula, if we forgot how can we find from this output? Alright. So it's a bit tricky because we are not familiar with this kind of technique. So that's why I want you to tick at the fit plot so you can generate the equation from the fit plot. All right. So you get this one. You select the at the blue plot, the weight plot here. All right. Right click. I think I need to zoom. All right. You right click and add trend line. Okay. So in the trend line option, I believe all of you have this function in your Excel. Okay. So we have exponential, linear, logarithmic, power moving average. All right. So we just choose the linear trend line, and then you can tick at the display equation on chart and display R square value on chart. Yeah. So you get the formula, the regression formula, model formula, and the R square. So when you see you comparing with the output here, we get R square 0.6, same with this one, R square 0.6. So from this one, you can use this formula for for your model. Okay, how can we use this model ataupun macam mana kita nak membuktikan model ini bagus? Alright. So first of all, we copy this function, this formula. So copy. Okay. Okay, tak apa. Okay, we copy the graph. We put at the actual data. Alright. So this is actual, actual. So how about weight in predicted weight? Okay, let's say we don't have this one. We just want to know weight just from the height data. So we want to use this equation to predict the weight, the actual weight. So first we put in this one equals, just follow the formula, 3.8181, okay, times shift 8 start, high, high, and then minus 132.99. Okay, we try. Okay, this one is our predicted value. This is actual. So we can drag all from top to bottom. So this is our predicted weight using our regression model. Okay. Am I too fast, or I need to repeat this part?
Please repeat.
Okay. Okay. How can we want to assure our model is good? Okay, from the formula. Okay, this one is the implication of the regression. We use the equation to make the predicted data. So this one is weight. We use weight as our independent, right? So we at the column E, we type weight predict. Okay, this one we put weight actual. So this is the real data. This is our predicted data. How can we put the predicted data? Use this equation here. Y or weight equals to 3.8181 x. X may refer to height minus 132.99. Okay, so let's do it together. You put below the weight predict, the first data equals 3.1818 times, you click at the height, just click at the height. No need to make it manual to put 56.3 because we just want to drag from the top to the bottom. The Excel will calculate automatically. Okay, so minus 132.99. So same with our equation here. And then you click OK, you click enter or just click the right button here. So this one is our predicted value from our regression model. One is our actual. This one is our predicted. So we go, just click here. Either you want to drag until bottom, so it will click for you, or you just click here, double click. All right. So this is our actual weight, this is our predicted weight. All right. So we have our first model for today. Congratulations. Okay, how can we comparing with this actual weight and predicted weight in more visual? So we select these two and we drag from the top to bottom, and then insert tab, we go to the line chart. So we can see here, sorry, the predict. So this is our comparing with actual and with predicted. All right. Not so precise and not so accurate because our R square is so high. Near to one, the best inside the actual predict. So that is the cons used from linear regression. But after we know the MLR linear, we will learn about non-linear. In non-linear, we can get the best can we get for the predicted predicted data, because it's not linear, it will go non-linear. Okay, that's we will on that I think tomorrow. But for today, I need you to understand the MLR. Get on it, I repeat. Saya ulang sekali lagi masalah. Nanti saya lagi kat sini.
Okay, Doktor, no problem.
Okay. Yang lain-lain, okay. Syahrul.
Okay, Doktor.
Alright. Okay. So this one is our first analysis using data analysis to test. Okay, so the next I want you to go to SSStat. Okay, we want to learn about SSStat and you activate the SSStat. Semua dah ada SSStat eh?
Yeah.
Alright, okay. Good. Ada bunyi burung tak?
Ada.
Saya kat
Unknown
outdoor ni.
nature.
Saya kat kampung. Sorry lah, minta maaf kalau mengganggu bunyi burung, bunyi kereta.
Tak mengganggu.
Oh,
Dr. Saiful
by the way,
ya.
yeah. Saya tinggal di Kelantan dan hari ni saya tak dapat pergi ke office sebab saya terpaksa duduk di kampung hari ni. So minta maaf kalau ada banyak gangguan bunyi-bunyian unggas-unggas ya. Alright. So okay, okay, continue. So You guys open your SSTAT? Already open? Semua dah buka SSTAT
Okay, done.
Sekejap
Alright, good. Okay, sila.
Nak tanya, minta maaf.
Ya, sila.
Bila saya buka Excel stat tu, dia tanya nak request trial key or enter stat license key tu.
Syarul guna yang free trial
Aha. Yang dia bagi link
so boleh close je, tak ada masalah.
close lah.
Close je. Sebab dia tak silap saya 14 hari tak silap.
Betul 14 hari saja.
14 hari kan? So untuk pembelajaran ni
Close saja.
sufficient lah.
Okay.
Alright.
Okay.
Alright. So my SSTAT is 2019. Alright. So I use the unlimited punya license. Okay, so how can we use the regression using SSTAT? Okay, after this we will compare the result from SSTAT, regression from using SSTAT and regression from data analysis. Okay, so for the regression we go to the modeling data, alright?
Sorry
Yup.
Tapi bila dia tak keluar tab macam yang dekat doktor punya.
Ya, okay. Ada tekan tak yang warna hijau ni?
Ni.
Ya, saya close tengok saya baik-baik. Okay. Bila dah ada install SSTAT, biasanya di tab di atas ni dia ada SSTAT. Ada tak?
Betul. Ada.
Okay. So you activate you activate SSTAT ni. Start SSTAT. Okay.
Okay.
Alright. Okay. So bila kita activate, biasanya dia akan keluar hang lah. Sorry, hang. Alright, dia akan keluar beberapa ada tak keluar ini?
Dia tak keluar macam tu. Dia keluar request
ada.
trial key.
Trial key. Ada trial key ke?
Tak apa, jap saya request dulu.
Ya. Just try. Saya tak sure untuk try key. Okay, we wait for Mr. Syarul. So everyone already have this step? Or ada yang tak dapat ke? Okay. We wait for Mr. Syarul to solve his problem.
Cik Syarul, boleh cuba share screen? Nak tengok.
Cuba share screen. Okay, saya stop sharing. Wait.
Dr. Saiful boleh stop presenting kejap.
Sekejap
Alright.
Okay.
Okay, dah keluar dah kat saya.
Cik Syarul, cuba
Sorry,
share.
dah ada dah.
Dah ada dah?
Saya dah buat dah.
Okay dah, semua dah okay dah?
Okay.
Okay, so
Sorry.
boleh start. Boleh, Dr. Saiful boleh teruskan ke?
Okay, boleh.
Boleh, okay.
Okay. Boleh Alright.
Sorry,
Saya sambung
Okay.
It's okay. Benda ni memang tricky sikit. Memang common lah. Untuk office. Alright, so we go back to our data. Alright, so you got this all the analysis here. So I will explain about the so we just focus on our linear regression. So you go to modeling data. Alright, click at the modeling data and then choose the linear regression. Yup, sorry.
Okay dah. Okay, tadi tak nampak slide. Okay, sekarang dah nampak dah.
Sorry. Alright, okay.
Okay.
Okay, okay, saya ulang balik Saya will repeat. I will not explain about the tabs, focusing on the modeling tab, modeling data here. So you click at the modeling data. Okay, click pada modeling data and then choose linear regression. Alright. Okay, so it will pop up with the linear regression box. Okay, so for the Y, we put weight. Sama macam yang data analysis tadi, kita boleh sama je. Okay, so for the X, we select high. Okay. So beside the general, okay. So before that, don't forget to tick at the variable labels. So the analysis will exclude the labels. So then option. Okay. This one, best model selection, I will explain after this exercise, but you just wait. Okay, this one, the first step is general, right? Okay, dah letak ke quantitative data weight ni?
Dah, dan
Alright, okay. So as explanatory variable or independent variable, we put the height.
Doktor.
Yeah, sorry. Yeah.
Okay, saya rasa doktor kena cuba macam okay, tak apa. Okay dah. Okay, boleh continue.
Macam mana tu?
Tak ada, saya salah sendiri. Sorry.
Oh, okay. Alright. Okay, so we proceed. Okay, saya ulang balik. I will repeat. Okay, the Y we choose the weight, actual weight, and then the X we choose the height, and then the best for the exercise we can get many function here. We can make a best model selection. We can get the validation, prediction. So it's up to you. Also, once if you got the missing data, we also have the function to estimate missing data using the nearest neighbor method or mid or mode. But this one we just kita perlu lagi. Okay, for the output here, we get the variant, type 1, perspective, we also get result for descriptive, we also get result for correlation. So this that's why SSTEP is good for data analysis for me personally. So okay, we can click OK. Okay, so here, okay, so we get this box. Just click OK. So we go to the statistics. So this one we can see here, R square is 0.6, same as our data analysis result, 0.6. So yeah, we also get the analysis of variance. Okay, this one I want to highlight for this one. Okay, this is our regression model. So weight equals to negative 132.66 plus 3.8 height. Okay, sama saja macam yang tadi. So kat sini, okay, dia dah bagi kita siap-siap. The regression of weight by height 0.6. Kita akan dapat yang ni. Dan juga kita dah dapat yang ni. Predicted actual dengan weight predict. Inilah. Sama je macam yang tadi. Before that, kita we use the manual. But this one they already generate for our data. Alright. So for the if we got many variable, we just use the SSTAT because it will more helpful for us to identify. Sebab orang seperti to supaya untuk tahu fungsi kita just apply sahaja. Ini apa yang saya pegang lah, sebab saya pun tak nak kita kena belajar juga basic. Dalam masa yang sama, kita tahu kat mana yang perlu kita ambil. Macam ni, okay, for this one, we know our R square, we know our model. That's all. If our model got R square is 0.1, 0.2, 0.3, we just don't use the model because it's not so significant to our objective. We find another way to make a model. Like we use ANN, or we just tak perlu gunalah sebab tak membantu pun dalam objektif kita untuk memodelkan prediction model. Pendapat saya, kalau above 0.5 to 0.9, I think it's acceptable because the what you call it, bila kita guna line chart, when we use line chart, it's not nampak logik sikit lah, kan, tak adalah beza sangat antara actual dengan predict. When you got the R square, get R square equal to 0.9, you can see the predict will mimic almost precise with the actual. If you get the 0.9, I'm very sure you get the best model for your research. Alright. So how can we get the the best for our model? So there's several methods. Like we find the most significant variable before we go to the model. We eliminate all the unnecessary variable. Okay. Yang ni saya akan cerita dalam kita gunakan data yang alam sekitar sebenar lah. I will explain to you when we using the real environmental data after this. Alright. So any question before we go to the best part? Not best part. I think this is the best part because we use the original data. Right? So can we proceed? Or you ada yang perlu saya ulang atau repeat sebelum kita bergerak ke data lain?
Kalau ikutkan semua okey, tak ada soalan.
Okay, Alhamdulillah. Semua okay, senang kejap lagi. Okay, so can you open our first exercise? Exercise River 1. Okay. Sorry. Kalau semua dah buka, sebut okey.
Okay, Doktor.
Alright, Alhamdulillah. Okay, semua okay Okay, this one, exercise river, okay. This is an actual clean and treated data from Department of Environment Malaysia. I got this data for my PhD from study to get the to predict the water quality index at the Semerak River in Kelantan. Right. So I show you this is the raw data. So ada tak yang kat sini guna data air, data sungai ke? Ataupun data apa alam sekitar yang ada?
Udara.
Udara, okay. Udara pun nanti saya akan sentuh udara nanti saya akan datang. Lagi siapa lagi? Yang Syarul buat apa?
Saya nak tengok macam saya sebenarnya buat orchid, pasal orchid dalam hutan. Jadi saya punya environmental data banyak berkenaan dengan temperature.
Okay, faham.
Dengan light intensity.
Okay, got it. So Dr. Amal, what field are you doing? May I know?
Mostly bioprocessing, Doctor.
Bioprocessing, Okay,
Yeah.
alright. So semua tak familiar sangat dengan data air,
I was teaching.
Not familiar with water.
I was teaching environmental subject during my PhD for lab, so I am familiar with the data.
Alright, okay, good. Okay, so we continue. Okay, this is raw data. The secondary data I got from Department of Environment. So this is raw, untreated, and unclean data. So we got here about 159 data from two river, Semerak River and Setiu River. from 2008 until 2015. So, okay, this one is I segregate and then come up with this one. This is the treated and clean data. So why I choose just 6 parameters because according to what index in Malaysia, we use just 6 parameters to calculate the water quality index, right? So one color yellow, green, brown, purple, just to identify the year, the different year for the same station, Sungai Semarang. Okay. Now I want you the exercise. I want you to make multiple linear regression model using WI as your Y, and all these variables, all these variables your independent variable using SS step. Okay, can we start now? And then we discuss together. All right. Okay. I give how many? 10 minutes? Yeah, 10 minutes.
Dr. Saiful boleh tak repeat sebab tadi suara doktor breaking. So we can't really hear what
Alright.
actually.
Okay. This one is and
We still cannot hear you, doctor. The line, I think the connection is not giving coverage.
wait. Okay ke? Okay ke? Jelas ke?
Sekarang pun jelas.
1, 3. 1, 2, 3. Hello. Hello. Hello.
Hello, okay, sekarang dengar. Tapi masa doktor explain, we couldn't hear
Yeah.
the sentence.
Oh, I see. Oh, okay, tak apa.
Okay.
Itulah yang saya tak suka online ni. Inilah dia. Tak
Itu
sampai.
dia.
Alright. Oh ya, minta maaf. Alright.
Doktor,
Okay. Okay, this.
part.
Sorry, pardon?
Dr. Amal, see the last part that you are saying just now. I mean, tapi it's okay, doctor. Doctor just repeat the whole explanation.
Okay. Okay, I repeat Okay, this one. Wait, sorry. Sekejap, wait. Okay. Okay, environment. I am working with environment data since my for using the secondary environment data, river water quality of river. So this one is the raw data I got from Department of Environment, Malaysia, for two river, Semarang river. So this one is untitled and data. You can see here we got a missing data, we got not calibrate data, we got not available data. So we need to clean and this data first before we go to the any kind of analysis. So if you guys using primary data, you use data you get from the lab work or from the your not from the secondary for all historic data. So it's good to you because you don't need to face this kind of problem. you need to treat, you need to clean, because if you not clean the or treat the data, you can get bias or not accurate of analysis you want. All right. So this is a several parameters for quality. We have dissolved oxygen, biological demand, carbon oxygen demand, and so on. We got the heavy metals here, and we got coliform and E. coli. So this one I got all of this from Department of Environmental Malaysia. Alright, so for you guys, you open the exercise 1. This is the treated and data. So why I chose only 6 parameters, because in what index, according to what index here, if you want to calculate water quality index, you just need 6 parameters, which are dissolved oxygen, biological oxygen demand, suspended solid, and ammonia. Okay. So you, I want multiple regression using this parameter. So I want you to make WQI index for your Y or dependent the variable, and all of this from DO to temperature your independent variable. Okay. Okay, jelas ke? Okay, is that clear?
Dr. WQI is dependent variable and the rest is X,
Yeah.
independent.
Yeah, Y is your WI, water quality index, and the S is the O to ammonium nitrogen. So I want you to make MLR by using stat from this exercise. Alright?